Today we are opening with Tim Driscoll, who is a developer with more than 12 years of experience, and Rositsa Kotseva, who is a Python developer at HedgeServe. They are going to show us performance profiling techniques to make our code base awesome. So please welcome Tim and Rossi.
Working? No? Oh, there we go. All right. Hi, everybody. Thanks for having us here. We're very excited to be at HackConf. First, a little bit about us. Oops, not that far. Who are we? My name's Tim Driscoll. I'm an application architect at HedgeServe. I've been programming for about 12 years, 10 of those at HedgeServe, and I love programming. I also love dogs, so that's just a warning to let you know that we will slip in as many dog pictures into this presentation as possible. So enough about me. Here's my colleague, Rosie.
Hello, everyone. My name is Heuristic Kotseva. I'm a software engineer at HedgeServe Bulgaria. I'm also a lecturer at HackBulgaria Academy, and I've been a software developer in the West for almost 5 years. And I like elephants, so if you notice something related to them, it's because of me.
All right. So what are we going to talk about? We've been programming for a while, and unfortunately, we've encountered lots of different performance issues, things running slow, and it's required a lot of different tools, a lot of different solutions. Unfortunately, there isn't one silver bullet that can solve all of your problems. So if that's what you were expecting, I apologize. But that said, there is general approaches that you can take to try to diagnose and attack the problem and approach what it is. So that's what we're going to do for you today. So without further ado, prepare for performance profiling techniques to make your code awesome. And Rose?
What we actually want to cover, a couple of things. We have a case study that we're going to investigate. In the next couple of slides, Tim is going to give you detailed information about our example. And while we are going through this case study, I'm going to follow good, let's say, best practices in investigating problems, not just performance ones. However, unfortunately, Tim is going to follow all the anti-patterns.
All right, so let's get started. So first, we'll quickly go through what our case study is. For this, we're going to do something we try to make it a little bit more interesting than your Hello World app, kind of based off of something we do. So we got this risk reporting, RESTful service. The idea here is we want to make it, something like a application we use, but small enough to fit within the slides. So we don't need to know all the details of the financial calculations that are going in there. Essentially, you just need to know that it's taking data from different market providers and doing some magic and sending it into a report for users. So this is how you could see the architecture as a diagram, and so you can see we got some currency API and evaluation API, and then some data access objects, and we're funneling into this position thing that's doing calcs, and then we're exposing that over a report, so that that does RESTful things for you. So, and if you don't like that, you can also view the architecture from the code. Similar idea down here. We're just saying that we've got, say, maybe like 5 modules. Most of them have to do with data access, so there's some database stuff going on there, some APIs we're calling, and then we got a controller that's kind of handling the details about serializing and deserializing for the exposing the API. So that's our architecture. So what's the deal?
And that sounds pretty cool. This is a powerful application. The users want to use it because basically they want to make millions and billions of dollars. It provides them financial information. However, there's a serious issue with it. It's way too slow. So, Tim, What are you going to do to fix that?
Well, don't worry, because as you recall from the first slide, I'm an application architect. So I already know what to do. So as you know, in most complicated applications, the database is the bottleneck. There's disk I/O going on there, network I/O. It's very hard to scale out, and so any serious application needs some serious caching.
Mr. Application Architect, sorry, but aren't you skipping a really important step here?
You're right. I am skipping a step. Before you can add a cache, you got to choose which distributed cache that you want to use. So I really like Redis, so we could do that. A lot of people like memcached. So I propose we spend the rest of the 35 minutes going over, the various pros and cons of each. How's that sound?
Hold on a second. Sorry, I have to interrupt you again. Let's
Oops, sorry.
yeah. Let's spend a little bit time talking about the requirements. So each system has different requirements, and we can separate them in functional and non-functional requirements. We already talked about our service, that it has to provide financial data. So we have our functional requirements. However, we haven't talked about the non-functional requirements. And why should we do that? Because the functional requirements tell us what a system's supposed to do. But the non-functional, they put the constraints on how a system is supposed to do so. So there are different kinds of non-functional requirements: availability, security, sustainability, efficiency, many others. However, in our case, our application is way too slow, so we have to take a look at the performance. The two main measurements that we use in performance are called latency and throughput. The first one basically gives you the information how fast the app can respond to a single request. However, the throughput gives you the rate of responding requests. In our case, we want to take a look at the low latency because this is the issue that we have. And nowadays, the developers, are not used to put just an average number of milliseconds per request. We want to use statistical data. We are fancy. So let's do the same thing. Our performance SOA for our case studies, 90% of our requests are supposed to be under 100 milliseconds per request. And per second, sorry. And 99% of the requests are supposed to be under 500 milliseconds. Do you agree with me?
After you described all that stuff about non-functional requirements, that did make a lot of sense. So now that I know what the requirements are, I think let's try to fix it. So in order to fix it, let's pull up another picture of our architecture because we like doing that. Here, little simplified version with a smiley face. And, I'm going to use this to intuit that's a word, what the problem is. And, looking at this right now, it reminds me of an issue we had early this year with the currency service. It was very slow. It's actually much more complicated than it sounds. And therefore, I know that as an application architecture and using my expert intuition, that the problem is with the currency service.
Okay, Mr. Application Architect, I agree that this is your position. However, I totally disagree relying just on anecdotal data. We need evidences from our current situation. Currently, you're neglecting to gather information based on our current problem and to rely on different data from previous incidents. So take a look at something else.
Oh, you want empirical evidence?
Yes.
All right, well, let me tell you this. I have empirical evidence. 1 second. Okay. Let's go to the logs. All right. So I'm going to take some logs from when our application was slow, pull them right out of production, real data from the real incident, and we'll do some analysis. So here we go, pulling them up. A little small, but that's okay because we got an arrow, points right to the problem. See there, right after we load the currencies, there's a large gap of time before the report finishes. Therefore, the empirical evidence, as we say, backs my original hypothesis that the issue is with the currency service. There you go.
Sorry, Tim, I have to be a bad person, but you skipped a really important step right now. You're a victim of the availability heuristic. If you haven't heard about it, basically the people decide to make their decisions based on the immediate and easy examples that come to their mind. And this is what Tim did a second ago. Basically, we have a huge amount of relevant data, but he decided to use just a small portion of that. And since we're talking about heuristics that the people follow when they have to make decisions, let's talk about other cognitive biases that are probably applicable to our situation. The first one is called anchoring bias. And it is when a person decides to use his first reference to an information. In our current situation, Tim, yes, he has a lot of experience, and he decided that the issue comes from the currencies. That was his first reference, and that's it. Let's look at the walks from there. Probably he's right. I'm not sure. But we haven't looked at anything else. Another bias is called overconfidence. Yes, he's our expert. We already talked about that. And he's neglecting to look at data that can prove him wrong. He looked directly at the walks of the currency. So, another bias that you're actually following. The third one, as you may notice, we have a dog here. It's called confirmation bias. And it's still applicable in our situation. That's because you look for evidences that are proving you're right. You don't look for anything else that can prove you wrong. Again, the logs from the currency data access object. And the last one is called bandwagon. It is when a person makes a decision and everyone else decides to follow him along. In our current situation, if I agree to follow him, the bandwagon effect will become stronger and stronger. And let's skip this one. To be honest, I think that the logs are lying to you. The logs are really powerful information, but they can be useful when we debug our code. And on the other hand, they can be a huge trap when we have to investigate performance issues. That's because we cannot log every single line of code. And at the same time, we could have logged so much useless information that we can't be sure where should we look at. Do you agree with me?
This is frustrating. I'll be honest. I've tried using my application architect intuition, and that didn't work. And then I thought I had some empirical evidence, and that didn't work. Now you're telling me about all these biases that I didn't even know were going on in my head. Honestly, how am I going to ever solve an application performance issue?
Now, here I come, and I can help you. Let's observe our code. How to do that? Well, let's talk about performance profiling. What is profiling? It is a way of gathering detailed information about the frequency and durations of function calls, of space and time, the complexity of specific program. When we use profiling, basically this tool can point us in the right direction. We don't need logs, we don't need anything else to start digging in the current problem. So, Tim, let's do this and use the profiling.
This is exciting because as an application architect, I happen to know lots of different ways to profile various applications. It's actually most languages and frameworks make it quite easy. We happen to be building a Python application, and in this case, we're using the Flask framework. So with just one line of code, you can add a middleware in there, and it will profile every single HTTP request, give you lots and lots of data about what the issue is. So after all this, it wasn't that hard. So let me go in there and do some profiling. This is our live demo.
Where's my mouse? Okay.
All right. So for this scenario, what we've done is we've run the profiler, and then we've taken it and we put it into a visualization tool. In this case, it's called SnakeViz. And this is not the only way you can look at profile. There's lots of tools out there. You can use a command line if you like as well. You're not like a GUI person. And it can be useful because if you can see here, it's there's a lot of text here, but you'll have to use a little bit of trust if you can after everywhere I misled you. But so you can see it logs every single application call. You know, we didn't have to instrument our code or add statements everywhere or do anything that's ugly, just a wrapper on top of it. And you don't have to know where the problem is because it records everything. Fortunately, in this case, I'm the expert, so I know it's with currencies. So I'll just search for currency. And then here we see there's this currency find all method, and it tells me that, oh, okay, actually it's only like 2 milliseconds or something. So I guess that's probably not actually the issue. So that's a little embarrassing in our live demo that I was wrong, but that's okay because the great thing about profilers is you don't have to know what the issue is. It could help you point you in the right direction. Another tool that's useful for that is the graphical view. So here we're looking at it as an icicle view, and in general you see the entire stack trace for everything, and bigger boxes are more time. So if you can look at big boxes and find the biggest box, then you can find what the issue is. So here, using my application architect finding big box skills, I can see that the issues with this getting security data, which has nothing to do with getting the currencies. So that's a little embarrassing. But and then I can go in here and I can actually search for that. And let me try that out. Oops. Okay, so here I got to get security data, and the per call is actually not too crazy, but then you can see that the number of calls are very high. So not only is it telling me, where in the code I could have a problem, but also giving me at least a good idea as what could be going wrong. Maybe I'm calling this too many times. What's going on there. The tool, doesn't let you just focus on the biggest thing. You can also drill down into, other parts of the stack. And if you don't like I like the icicle. I'm an icicle person, but if you like, you can do like the sunburst. Similar idea, larger radius is our bigger. But yeah, but enough playing with this. I could play with it all day, but now we know what the problem is. So let's go back into the code and fix it up. All right. Okay. Ooh, I got my pointer too. All right. So I know what the issue is. So we're gonna have to go into. We mentioned it's Python, so you're gonna see some Python here. This is our Python code in here, and normally we don't have comments that tell you exactly where the problem is, but in this case we do. So we have, you can see we're iterating through the securities, and oh my goodness, we're calling another function. It's also iterating through the same list of securities. That certainly sounds like a sort of n squared big O thing going on there. It's a little embarrassing, but that's okay, because we can fix it. So let's do some coding. All right, with that out of the way, got some new code. All right, here we got a little prettier. As you can see, I've changed it to iterate through securities once. I built a dictionary, and I do some constant time lookups. So now we're more at like a sort of a linear complexity of our algorithm. I have to say, overall, I'm pretty impressed with my coding skills. Thank you.
Now, Mr. Application Architect, sorry, I saw that you changed the code, at least the doc did that. However, I totally disagree relying just on this. We talked about profiling. Let's use this again.
All right, that's fair. I feel like you've given me a lot of good advice, so I'll bear with you here. Unfortunately, profiling's so easy that it's just as easy to profile before and after. So profile, and here's the new visualization. As you can see now, we don't have that get security data. Now it's something to do with, I don't know, like the request API, making a request to get valuation security data. Anyway, point is, it's, if you look at the top, it's like 10 times faster. So certainly a good start, I would say, and definitely deserving of the GIF that we saw earlier.
Yeah, now I think you deserve the bunny. However, I have to be bad again. Sorry about that. However, when we have problems, we cannot rely just on one single request and profiling just one single request. And what will happen if in 2 weeks from now we have the same issue? How are we going to fix it next time?
Oh,
Yeah, well,
no, I don't know.
yeah, you don't know. So let's think about it before having this issue again. We should be able to monitor our data. And there are a lot of powerful tools. In our real life application, we use Kibana. It is based on Elasticsearch and give us detailed information. However, in the beginning, when we talked about the non-functional requirements, we defined only our SLAs. We didn't put an actual number for our performance benchmark. And yes, the profiling gave us the information where the issue comes from, how much time it takes, but we need to gather this information. And how we do that? We use Kibana. So can
Oh
you
yeah,
give
I
them
can
more
totally help
data?
here. Okay, I'm excited. So uh, essentially, what we do here is we take our application logs, we do some parsing with Logstash, and they get shipped over to an Elasticsearch database, which is good at doing calculations with large numbers. One of the cool things it can do is it can easily break your data into percentiles. So um, as Rosie mentioned, the cool thing is to do that because if you just have an average, a lot of times you can miss like high peaks in performance that get averaged out, and you could try to use max, but then one person distorts that. So percentiles are a nice way of kind of taking a balance of the two there. And here we can see, over time, what that we're actually a little bit above our SLA. So I guess afterwards, I'll have a little work to do as far as fixing this. But the neat thing is, you can correlate this stuff with the logs, and I can pull up and find out what this stuff is, and then break into my profiler again and fix different instances. So pretty neat tool to have in your belt.
I can say that it's also a pretty powerful one. However, we need to ensure that our application keeps running this fast. And in order to do that, we need tests. As you already may notice, we don't have existing tests. So it's a huge issue for us. Next time when we have a new system and once we define our performance goals, that's the time when we have to define our performance tests. I'm not just talking about performance tests. We need to define different kinds of tests, load tests, stress tests, and many others. However, we need a way not just to monitor this, we need a way to gather this information and go through it every day just to make sure that the new changes don't affect our performance. How to do that? There's another tool called APM. And what is APM? It stands for Application Performance Management System. It's a huge system basically. There are a lot of them. I'll give you just a brief information about it, not a detailed one, because To be honest, it's a subject of a whole other presentation. APM gives you detailed information about a trace back to a specific line of code. It gives you the performance per single request, per multiple requests, not just web requests, the database transactions. It gives you all the application dependencies. It can give you a centralized application data and a lot of other things. For me, the most powerful thing is that it's a tool that can be customized. The development team can decide what can be added, what can be excluded, etc. And since we're talking about APM, the most popular ones are on the slide, at least these are the systems that I know, and I've used a couple of them. These are the links to the APM systems. After our presentation, you can open them, double check what are their pros and cons. For me, the biggest difference is the language. On one hand, Lupe is an APM that supports only .NET and Java. On the other hand, Stackify Retrace supports Python, Ruby, .NET, Node.js, and many others. So it really depends which language you want to use. And the other thing, at least for me, is the pricing. They have totally different pricing structures, so you have to decide which one you want to use. So at the end of our presentation, I'd like to summarize what we did. The first thing is that we really suck at writing code. Sorry to tell that, Jim. No, let's be serious. We were able to talk about the functional and non-functional requirements of an application. When should we discuss these? How important are they? And based on them, we need to investigate our problems, because we can just spend time digging in different files, walks, etc. And we need to have a starting point to do that. Then we talked about different heuristics and biases that the developers, and not just the developers, all the people follow when they have to make a decision. In our case, a design decision. Where should we look at and how to approach our problem? However, it's pretty hard to understand when you're following these biases. In our case, we want to show that Tim followed them, and in our day-to-day work, we are used to pair together, and I was the developer that it came to my mind, hey, you're following stuff that we're not supposed to do. So that's why we used profiling, in order to overcome those biases and heuristics. At the end, we talked a little bit about tests, when we have to write them and why they are important. We talked about APM. There are a lot of different tools and systems that you can use to fix your performance issues. Just be self-aware what you need and where the problem comes from. And at the end, we were actually able to fix our performance issue. So that was pretty cool.
Yeah. Cool. So I promised to be as many dog pictures as possible, so this is my last chance to try to get this one in here. That's my dog, Junie. But in seriousness, thank you very much for having us. Thank you. We had a fun time.
Check. That was really, really helpful. So we have around 10 minutes for questions. Anyone willing to ask a question? Come on, don't be shy. Okay.
I thought you were going to throw it.
Hello.
Hi.
So are you decorating your code in any way in order to run the profiler? Or it's just you feed your app and it profiles it? I don't know. Are you decorating your functions in a certain way so that the profiler can actually work? Or are you just feeding the app to the profiler?
Oh, let me see if I can rephrase the question. Do you have to write your functions in a way that make it
Yeah, exactly.
Yeah, that's a good question. We technically, for most profilers, no. You don't have to. There's nothing within your code. It's all at a level higher. Python uses it kind of hacks into the debugger, so just in the way you don't have to change your code to debug. you don't have to change your code to run the profiler. That said, if you have giant 100-line methods and it tells you that method's slow, that could be a little bit of a challenge. But there's probably more than one reason not to actually have methods that big. But yeah, that's a good question.
Okay, thank you. And if I can ask a second question, is that okay? Yeah, so you introduced an application management system in one of the last slides. Yeah, so how's that different from, the monitoring service that most cloud providers basically provide? If you kind of put your app in the cloud, you get those monitoring services out of the box. Do you use those management systems only for on-premise applications, or?
Not a lot of differences between those two. Basically, APM stands for, it's an abbreviation for these kind of systems. You can combine different tools and functionalities from a couple of systems at the end, so you can say that this is an APM. However, in our real-life application, Kibana is not called APM, it's just a monitoring system. And we actually have the functionality to upgrade it to an APM and add a couple of customizations. So it's up to you to define if you're using just a monitoring system and if you just want to combine the walks in a centralized place.
Okay, thank you.
Let's get some more questions. Anyone? Come on. Don't be shy.
Friendly.
No questions? Okay, so one more time, thank you, Tim and Rossi. That was awesome.
All right, thank you.